Trigonometric ratios. So to explain what the trigonometric ratios are and define the functions, we start with a right triangle. Let's remember right triangle has a right angle, and then let's say T is one of the angles right there, and the side opposite to T is called opposite. The side that is adjacent, the side beside the hypotenuse that is next to T is going to be the adjacent. Sometimes they say adjacent is the side between T and the right angle. And so that's the description of the right triangle. Now let's define the ratio sine of T. That's the opposite over hypotenuse for sine of T. Then cosine of T is adjacent over hypotenuse. And tangent of T is the opposite over adjacent. See, the numerator is the same as sine of T. And then cotangent of T is adjacent over opposite. Other things to notice, tangent of T is just sine of T over cosine of T, and cotangent of T is the reciprocal of tangent of T. Secant of T is the reciprocal of cotangent of T. Cosecant of T is the reciprocal of sine of T. So let's, one thing to mention in very beginning, when we're saying sine of x, for example, sine of x over x, this x is not multiplying sine. This x is what goes inside the function. It's the input of the function. So you cannot simplify the two of them together. The other thing to notice is sine of x plus y is not equal to sine of x plus sine of y. There's a formula for that. Also, there's an identity that explains what sine of x plus y is. If let's say if x is 0 and then y is another value, and then this is true, but beside that, for a general format of x and y, this is not true, and this is never true. Find other trig functions if sine of theta is equal to 3/5 and theta is between 0 and pi half. So we're looking for all trig values for theta if sine of theta is equal to 3/5 and theta is sitting in the first quadrant. So now what we had in the previous page was that we had the right triangle, and we start from there and find all the values. Interestingly enough, if you all the right triangles that have theta as an angle, and there are similar triangles, so I can choose whatever right triangle I want. And over here, what I choose is, I remember sine of theta is equal to opposite over hypotenuse, so I choose a right triangle like this, and I say if this is theta, then the opposite should be 3, the other side should be 5. Now, using the Pythagorean theorem, I can figure out what the adjacent side is, and the adjacent side is going to be 4. So cosine of theta is going to be 4 over 5, tangent of theta is going to be 3 over 4, and secant of theta is going to be 1 over cosine of theta, which is 5 over 4, and so on and so forth.